relatively balanced remodeling and a decrease in bone mass, but dynamic loading within physiologic limits increase bone mass and induce osteogenic activity. The characteristics of force applied to dental implants are based on the magnitude, duration, direction, type, and magnification. The magnitude of bite force varies from 42 to 1245 newtons. Force duration of axis cyclic loading of an implant or prosthetic components, even with very less magnitude of force, can cause failure and fracture of the implant components. Bone is strongest when load is in compression, 30% weak when subjected to tensile force, and 65% weak when subjected to shear force. These are the various designs of the thread of implants: V-shaped, buttress thread, square or power thread. The phase angle of the thread can change the direction of the load from the prosthesis to abutment to a different force direction at the bone. Extremely angulated implants or in patients with parafunctional habits, the amount of force that is exerted is very, very huge. Functional surface area is that area which actively serves to dissipate the compressive and tensile non-shear loads through the implant bone interface and provides stability of the implant following surgical placement. Hence, there is maximum stress in the crestal area. A smooth-sided tapered implant allows for a component of compressive load to be delivered to the bone implant interface dependent on the degree of taper. Threaded implants with circular cross-section allow greater functional surface area to transmit compressive load. Reverse taper in the minor diameter of threaded implants increase the thread depth in the crestal region, resulting in dramatic increase in functional surface area at the crest of the bone, where the stresses are the highest. Implant length: in poor D3, D4 quality bone, functional surface area must be maximized to optically distribute occlusal load. Softer the bone, greater the length that is suggested. Crestal module consideration of implant is the transosteal region from the implant body and is considered as the area of highest stress. Smooth parallel sided crestal module will result in shear stress in this region. Hence, an angulation of more than 20 degrees with a surface structure that increases bone contact decreases the risk of bone loss. To summarize, the process and consequences of force transmission into the bone depends on the nature of the force applied, the design of implants, the bone implant interface, and the reaction of the bone tissue to the mechanical environment. Tapered implants are best than cylindricals to avoid punching stress. From a biomechanical perspective, the implant abutment junction should have a design that reduces the peak bone implant interface shear stresses and strains. The bone implant interface close to the crestal bone level increases the magnitude of stress.